Molecular geometry, sp2 hybrid orbitals. In this tutorial, we will be going over sp2 hybridization of boron, boron trifluoride example, sp2 hybridization of carbon, methanol example, sp2 hybridization of sulfur, sulfur dioxide example, sp2 hybridization of carbon, ethene example, and then some practice at the end. sp2 hybrid orbitals. The first example that we're going to look at is boron trifluoride. So consider the bonding in a molecule of boron trifluoride, BF3. The orbital diagram for the standard atomic orbitals in a boron atom is 1s2, 2s2, 2p1. And if we focus just on the second principal energy level, we can see the electrons filling in as 1s2 and then the 2p1. So if we were to draw the boron-Lewis symbol based on this electron configuration of what we just see right here, you might be tempted to put your boron symbol, 2 dots at the top representing the 2s orbital, and then 1 electron on the side. In the ground state electron configuration for a boron atom, there is only 1 unpaired electron available to bond with the 3 fluorine atoms, like we see right here. Right now, only 1 bond available, and that's a problem. The trigonal planar geometry in BF3 can be explained by the hybridization of 1 2s orbital and 2 2p orbitals on the central boron atom. The remaining 2pz orbital remains unhybridized. So if we mix the 1 2s orbital and the 2p orbitals, we get 3 sp2 hybrid orbitals. So 1 electron in each. And then we have 1 unhybridized p orbital that's just left alone. So when we draw the boron-Lewis symbol here, we still have our B, but now we have 3 electrons in 3 different orbitals. So we can say 1, 2, 3. Boron's 3 valence electrons occupy the 3 sp2 hybrid orbitals with parallel spins according to Hund's rule. The 3 sp2 hybrid orbitals all have the same energy. In other words, they're degenerate. So here is our Lewis model for BF3. A central atom with sp2 hybridization has 3 sp2 hybrid orbitals, 3 electron domains, with a trigonal planar electron geometry with bond angles of approximately 120 degrees. So we can see our 3 electron domains. 1, 2, 3 bonds coming off of the boron, because right now we're only interested in the hybridization of our central atom. So 3 bonds, that means 3 electron domains. And the fastest way to figure out hybridization is to say to yourself, okay, I have 3 electron domains, so I'm going to think about this in terms of 3 letters. 3 letters need to be involved in my hybridization. So 3 letters, S, P, 2. 3 letters in total, that is my hybridization. And we're going to use that little trick to help this go a little bit faster. 3 electron domains can be observed as 2 single bonds and 1 double bond. So for example, the central carbon atom in methanol, H2CO, is sp2 hybridized. So how many electron domains do I have? Well, 1, 2, 3. So 3 electron domains, because remember, that double bond right there is going to be considered 1 electron domain. 3 letters involved in hybridization. So 3 letters, sp2. sp2 hybridized. 3 electron domains can be observed as 2 double bonds and 1 non-bonding electron pair. So the example here is the central sulfur atom in SO2, which we know is sp2 hybridized. Now how do we know that? 1 electron domain, 2 electron domains, 3 electron domains. So 3 electron domains, 3 letters, sp2. What is the hybridization of the central carbon atom in ethene? Well, you can pick either carbon atom. It's not really going to matter. So let's look at the number of electron domains. So for this carbon, 1, 2, 3. So 3 electron domains. So the hybridization here must be sp2. 3 electron domains, 3 letters, sp2. And that applies to either this carbon or to this carbon. They are both sp2 hybridized. Let's do a little practice. How many of the following molecules have sp2 hybridization on the central atom? So the first thing that you need to do is look at all of these molecules, and then you say to yourself, okay, what is my central atom, and do I know what the structure looks like? And some you might know off the top of your head, and some you might say, I need a moment to draw these out. But for the sake of time, let's say that HCN looks like this, and then you say to yourself, okay, how many electron domains do I have? Well, that's 1, 2, 2 electron domains, 2 letters. So in our next video, we will be talking about this in more detail, but this would be sp hybridized, 2 electron domains, 2 letters, sp. Now our next one, SO2. We just did this, but it's okay. So the structure looks like this. How many electron domains? 1, 2, 3. So 3 electron domains, 3 letters, sp2. OCl2. You might need to draw this one out if you're not familiar with it. So we look at this and we say, well, how many electron domains? 1, 2, 3, 4. 4 electron domains, 4 letters, sp3 hybridized. And finally, even though it is beyond the scope of this course, we're going to include it anyways. XeCl2. It looks something like this. So how many electron domains do we have? 1, 2, 3, 4, 5. So technically we would have 5 letters. And if you take chemistry in college, you might get into this a little bit more. So it's 5 electron domains, and the hybridization is sp3d, which you are not responsible for, but we look at it and we say, well, it's definitely more than 3 electron domains, so it is not sp2 hybridized. So the correct answer here, of course, is that there is only one molecule here that has sp2 hybridization, and that is the SO2 molecule. So what did you learn in this tutorial? We talked about the hybridization of boron, carbon, sulfur, carbon, and then we did an example at the end. Need more help? Feel free to contact me. Have a great day.